Hey guys, all right, in this lecture we're going to cover ornithischian dinosaurs, my favorite, because these are the ones that I actually study. So let's review here of what differentiates between an ornithischian and a saurischian, so within the dinosaur realm here. And so if you recall from the previous lecture, we were able to split between ornithischians and saurischians based on the orientation of one of the three hip bones called the pubis. So in ornithischians, that pubis is going to be pointed more posteriorly, whereas in saurischians, it's going to be pointed more anteriorly. So for this lecture, we're going to be looking at this group here on the left, the ornithischians. So this first major character of the retroverted or backwards pointing pubis is that I just described. So I'm not going to go into any more detail on that idea here. You can see it in the images as well on the right. But what else would help us identify between an ornithischian and a saurischian? So if we didn't have, let's say, part of the hip bones, how could we then tell the difference? So of course, there's other characteristics. That's the hip bone one is like a dead cellar, though, usually if we have it. So other characteristics, this one here on the bottom is ossified tendons. So tendons in general will attach bone to muscle or muscle to bone. So therefore, they're going to act like tethers to help hold together our body so that way it doesn't fall apart as we move around. But these ossified tendons, what they do is that they will calcify sort of like into a bone-like material and help uphold the tail of these animals, so therefore it doesn't actually drag along on the ground. More on this later on as we progress through the lectures. Other characteristics that we end up having is a gastralia, so stomach ribs. Weird, right? So what we have is in ornithischian don't have these gastralia. I'm sorry there. So in this image of Tyrannosaurus rex, which is a saurischian, they end up having all the various different ribs that all dinosaurs have and most animals do. And then they have an additional set of stomach ribs just underneath that called gastralia. Crocodiles also share the same thing as well, too. So it's likely that based on the idea of extant phylogenetic bracketing, being that crocodiles and saurischians have it, is that that was the more ancestral condition, and therefore then ornithischians lost these at some point during evolution. But what's the point of them? Why would we have them? Well, the purpose is that of what we believe is that it actually helps uphold the kind of guts of the animal, so therefore they don't keep falling down because of gravity. So why is it that the ornithischians would lose it? Well, that's still a little bit of a conundrum in the functionality of the gastralia, but that's something for future researchers to figure out. A couple other characteristics. The predentary bone is going to be on the very anterior and most cranial end of the skull, and it will sit right on top. So think of it as like a, doesn't function like one, but it's sort of like a mouth guard right on the very front of your noggin. And so this is going to help these animals more so kind of use their mouths as like a appendage to grasp onto leaf matter that they're trying to eat on a daily basis. The jaw joint then is going to be set all the way in the very back beyond the kind of maxillary upper tooth row, which ends right about here or so. So that's going to be a bit different than what we see in other animals. And so that's going to be another characteristic. So this is where the jaw joint is right here, where the animal would kind of move their jaw to open and close it. And then one other characteristic is that their teeth will end up having these beautiful ridges. And depending on whether you're looking at a duck-billed tooth or a horned dinosaur tooth or a pachycephalosaur tooth, they're all going to be a bit different. They are going to be a bit different, but each of them will end up having some sort of ridges to them, rather than more of like a conical tooth like we see in saurischians. So let's start going down the line on the three major groups of Ornithischia, so that way we can understand what sort of dinosaurs are in here. I would absolutely love to go into a lot more detail on all these different other ones and some really weird anatomies that some of these animals have, but we only have so much time in this course, particularly in the online version of it, that I'm going to kind of give you some of the highlights as we go along of some of the cool ones, while also maintaining the major groups that we have. So the first group we're going to look at are the thyreophorans, or the armored dinosaurs. So these are divided into ankylosaurs, and so like these armored tanks that we would see in like the various different kid toys, and stegosaurs, so they have like those triangular plates on their back usually. So between these two, they functionally kind of were like tanks. They were able to probably move quite slowly. They had lots of armor to them. That armor was likely there for defense mechanisms, so therefore they couldn't be attacked from behind or from above. So that was really useful and helpful because of their slow capability to move, because of the increased amount of armor. They were quadrupedal, although their ancestors were bipedal, meaning that they walked around on 2 legs versus 4 legs. So that's kind of what we've got here on the right, of Scelidosaurus being the ancestor. And then lastly, they were all herbivorous. So they had these leaf-shaped teeth with these little ridges on the very end, on the kind of margin of it, another ridge towards the very center. So very characteristic type of tooth that we would have, or that they would have. So if we split into these two groups, we have Stegosauria in this case here. So these are the ones with the plates on their back. Sometimes they had large spikes instead. So it all depended, but they had some kind of an ornamentation of plates or spikes usually. Not only on their backs, but sometimes coming off of their shoulders and other areas of the body. So what were these plates useful for? We're not 100% sure, but we have a pretty good idea based on modern organisms, is that they could have been used for thermal regulation, because we do understand that there was some blood vessel matrices and canals found in these. So therefore, there might be an aspect of thermoregulation. But the other part, which is more likely, um, is species recognition or sexual display. So maybe they might have had a capability of changing the color of it due to the amount of blood that they forced into this area. A whole variety of things. Unfortunately, we won't know for sure what their primary functionality or the biological role of these were, but we can probably have a pretty good guess of what it is. The other characteristic that these ones have is they have these large dermal spikes on their tails. So there was a Far Side comic that came out way several decades ago that coined the term the thagomizer. And that's kind of stuck around here amongst paleontologists as well too. So we usually use that as a term here as well. But this, which is pretty obvious in terms of its functionality, would be for defense and combat. We wouldn't want to be hit by one of these things. So then if we look at the other side of Thyreophora, we have ankylosaurs. Or ankylosauria. And they take that dermal armor idea that some of these stegosaurs did just in the previous slide, really like to the maximum extreme. They cover their skulls with armor. They cover their backs with armor. They cover their tails with armor. Sometimes they have a club on the very end of their tail. They just became massive battering rams. And that's kind of what these remind me of. So if there really is a tank dinosaur, this is it. So these divide into two groups as well too. One of them, we have what are called the Ankylosauridae. I know, kind of confusing that the major group is called Ankylosauria, and then we have a subdivision of it called Ankylosauridae. I didn't name them. This is how they named. This is whoever decided initially. This is what they named it as. And then we have the other group called Nodosauridae. So what distinguishes between the two? Ankylosaurs, like that pictured here up at the top of a dinosaur called Zool, named after, yes, you guessed it, the big baddie from Ghostbusters 1, is they will have this massive club on the end of their tails. And so that would have been used to kind of smash things around and all sorts of things for defense and combat. So here's a couple other examples. So Ankylosaurus being probably one of the first ones named, Zool being a very good characteristic one as well too. But then the other is Nodosauridae. So these ones are characterized by two things: that they, one, don't have this bony one. They don't have this kind of bony club, so there's not much to show there. So they just have a tail that just extends out like a normal tail would, and then just tapers off. But the other thing that they also have is that they will, around their necks, like in this one here on the bottom right of Boreopelta, they will end up having these collared spikes that go all the way around kind of the neck area. So adding a little bit more protection, something that Ankylosauridae don't have. Moving on, we going to move into the ornithopods. So ornitho meaning bird, pod meaning foot. So these are the bird-footed dinosaurs. They're not necessarily birds themselves, so don't confuse yourself there, but that's how they were named initially. So we got to stick with the name as it is. Now, the idea is that they kind of have feet that will have sort of a resemblance towards birds. And so when paleontology was getting its startings in the 1800s and 1900s, we didn't have a whole lot of fossils to base this off of. So we saw some trackways and we started naming these animals ornithopods because we thought that they might have had a closer resemblance to birds, not realizing that later on they actually would be further away from birds than something like a T-Rex. But let's talk about these guys. So they are some of the most studied dinosaurs on that we have, and the reason for that is because they have a huge abundance of preservation. They will preserve in massive bone beds, so we have like huge populations of them that preserve, so we can identify demographics of these animals, not just like a single T-Rex just laying around in a rock in one place. We have eggs and nests of many of these different species. We have skin impressions, stomach contents, a whole slew of different things that we don't actually have, or very rarely do we have for all other groups of dinosaurs. So a lot of people study these, including myself as well too. But I study them for a different reason because I actually cut up their bones, which I'll cover that in a future lecture on paleohistology. So one thing that these guys don't get a claim for is their cool structures because they really kind of don't have any. They don't have any defense structures, but that's because, but as a result, one of the things that they would do is that they would gather in herds. So, like we see cattle or zebras gathering around, that's what they did. So that was one of their major primary mechanisms for defense, to be in larger groups to help defend as a collective rather than as a single individual. They did have global distributions, including latitudinal extremes all the way up to the North Slope of Alaska down to Antarctica. So they were pretty much everywhere on this planet. Another neat thing about them is that they were facultative bipeds. So what do we mean by that? Is that they were predominantly quadrupedal, so meaning walking around on four legs, like we see in all of this here. Their body weight just simply necessitated the need to walk around on four legs. Otherwise, their back legs wouldn't be able to withstand that for longer periods of time. But they were able to rear up, kind of like a dog or a bear does, to be able to reach up higher, maybe branches for different nutrition, to make themselves bigger in terms of a defense mechanism, or whatever the reason might have been. They were able to do that. In addition, some of them were able to actually then run on their hind legs for perhaps a shorter period of time, not too long, but for a shorter period, to perhaps maybe escape away from a predator. And then lastly, what we have are that they had a really nice complex dentition, which I'll cover here over the next couple slides, because I've actually done a bit of research on that. But just before I jump into that, if we look at their evolution here, so we have Ornithopoda, then we had Iguanodon kind of popping up a little bit earlier. So this isn't a duckbill dinosaur, but it's kind of leading into those. You might recognize this name from our first lecture and the history of paleontology, when we talked about Mary Antell finding an Iguanodon tooth. Then we kind of divide it into later on into these groupings of duckbill dinosaurs. So before we do that, though, let's look at their dentition. So what they have is the most complicated dental pattern and dentition of any animal that's ever lived on this planet. And I'm not over exaggerating this just because I like them a lot. It's true. So what is it that made it so complex and so kind of intriguing to study for me? Well, they have their teeth lined up into a dental battery. So if you look at this zoomed in image on the bottom right here, that's what's zoomed in from this image, this kind of red box in the top right. These are all individualized teeth. So I'm just going to grab a pen here and just draw and highlight a single tooth here. So this is a single tooth right there. So here is another one, right? So there's another single tooth. And then another one here. I kind of bled out a little bit on that drawing. So each of these are individualized teeth, but we don't see the entire tooth. We don't actually see the entire root of the tooth either, which is going down a little bit further below that because there's overlapping teeth constantly. So there's multiple teeth within each what we call tooth family. So each row of teeth here, a column in this case. So in this case here, there's 1 and 2. In this case here, there's 1, 2, and a third one starting to erupt at the bottom. So they have multiple teeth. So imagine like you having a mouth full of teeth just constantly popping out of the exact same spot. That's a lot of teeth, to the point where they had about 3,000 teeth in their mouths as adults at a single time frame between their upper and lower jaws. So then how were these teeth held together? And this is the study that I was had a privilege of doing. So I had made a histological section of an entire dental battery. So this is a scale for you of 10 millimeters, so 1 centimeter. So this is a pretty long entire section that we made. And so what we have in this case is that each of these teeth were held together by a soft tissue structure, which in these images is actually missing because soft tissue decays away over time and degrades away. So what we were able to identify is that soft tissue structure was actually there because the structures that are preserved of the bone look like that there's like a pulling structure that would have attached to it with various different fibers. And that structure is called the periodontal ligament. And we have that exact same thing too in our teeth, which helps hold our teeth into the jaw socket. So if our teeth were immediately embedded into the bone, anytime we would grasp onto some kind of food and try to grind it, our teeth would crack because those forces would be dispersed into the tooth and the tooth would crack very easily. That's not good news for us. Same thing with other animals that have to grind their foods as well too, like these herbivores, these animals that eat plants. So what they had is that because they had so many teeth, they had these attached by periodontal ligaments. So when they were grinding this material down, this food material, they weren't cracking their teeth as they were going. But at the same time, they were grinding their teeth on that layer of so if we imagine this is like a top-down view of their jaw, and we're seeing all the different teeth kind of looking at it, they grinded these teeth down to the very end of it. So they actually never shed these teeth, unlike how some people thought of this in the past in terms of research. This study that we did, we showed that they actually grinded their tooth all the way down to the very end. So they never shed them. So these are split into 2 major groups, and the way that we define these is actually primarily based on their skull morphologies, so their skull structures. And so one group, we define the Saurolophinae, which are closer related to a kind of iconic one within the group called Saurolophus. This is actually one of the group, or this is the dinosaur Edmontosaurus that I study within this group very rigorously within my research, versus the Lambeosaurines, which are more closely related to Lambeosaurus. But in this case here, what we end up having is in Lambeosaurines, if we look on the bottom right image, they usually kind of have some kind of a cranial crest structure that will go through the back of the skull, whether it's something that kind of goes upwards towards the back. You might have seen a couple of these in various different dinosaur toys and different movies that you've seen before. The Saurolophines don't have any of that. So they're even more boring. If anything, they just have a bit of a bump, maybe sometimes around their schnoz, but they're even more boring in that sense. All right, moving on, we're going to now move into the group called Marginocephalia, which is the third major group within Ornithischia. So that's what we're seeing here. And this is divided into 2 other smaller groups, but they are called the Pachycephalosaurs and the Ceratopsians. So we're going to look at those 2 individually because that's what's going to allow us to actually identify between these 2 major ones. So in Pachycephalosaurs, these are the dome-headed dinosaurs that everybody thinks at some point they were kind of butting heads against each other to for some kind of combat or whatever it might have been. There's a lot of research that's been going back and forth and back and forth. So every few years I have to update my slides. And so at this point, I'm just going to kind of leave my slides as is, and I just explain it to say there's research pointing towards that there was head biting behavior. And then there's also research showing that there wasn't head biting behavior. The idea of there not being any head biting behavior is because there's actually blood vessel canals within that structure of the bone that would kind of grow outwards. It's kind of big mass that would come out. Um, so the idea was that if they were bumping each other in the head with these, then they could potentially bust some of these blood vessels, some of these blood vessels, which would cause issues for these animals, perhaps do have some kind of a stroke, an aneurysm, whatever it might be, do brain damage. That's kind of the general thought there of why we wouldn't have headbutting. Now, the idea of headbutting itself, the positive or the evidence for that would be that this structure is incredibly thick. So if we look at the histology here of this, just a cross section of this skull, this being the top of it, this being kind of like where the brain would pretty much kind of sit somewhere down here. This is a really thick part of the bone. And so there is quite a bit of protection here. So you can kind of decide amongst on your own, which is it. In my opinion, if you were to ask me, they probably did both. They probably did use this for some headbutting components and then also for some species recognition and things like that. But what did, so as I kind of clued into here is that what did they use this sort of structure, this dome-headed thing, if they didn't use it for headbutting, was for species recognition and sometimes a sign of age and maturity. So we have a pretty well-established spectrum of ontogeny, meaning through the life cycle of a certain group of species of these Pachycephalosaurs. So for a while, at one point, we thought that something called Dracorex was a completely different species here and shown at the very top, from something called Stygimoloch in the middle to Pachycephalosaurus here on the very bottom. They're all part of the group of Pachycephalosauria. But eventually there was some research done by various different individuals to identify that actually this is more of a continuation of a life cycle. So Dracorex is the younger version of the juvenile, being then Stygimoloch like the teenager, eventually evolving into Pachycephalosaurus, the adult. However, as there is with new data that always pops up, there's the caveat as well too of, well, that actually might no longer be the case. And just in short, the reason why we know that is because I forget exactly how it falls in, but between these three, one of them doesn't live and we don't find it at the same time in the same area as the other two. So it's possible that maybe some of this is actually a spectrum of, I believe it's Dracorex evolving into Pachycephalosaurus, and then Stygimoloch perhaps being a completely different species of its own. Forget exactly how that is. I'll put up a paper here for us if you're really curious, or you can shoot me an email if you're curious more on it. And then on the opposite end of marginal cephalia, we have the ceratopsians. So these guys are some of the most iconic dinosaurs, some of people's favorite dinosaurs because of these massive frills that they would end up having. They have horns on their head, not all the time, but many of the times. And they form this really large rostral bone on the very front that will develop into a beak. And that's part of that aspect of the griffin mythology, where we looked at Psittacosaurus and Protoceratops being kind of combined with the anatomy of that of like a lion or an eagle because of this beak format to fit the story of a griffin. The other part that they end up having is their jugal bones. So these are the cheekbones will flare out hugely outwards. We can't really see that here, but they'll actually be kind of coming outwards out from their cheeks, and they'll flare out, and that'll help with a bit more muscle attachment in that area as well too, turning into horn-like projections towards the very end to kind of make them look wider, maybe scarier and things like that. So within this, there are two groups of ceratopsians. There are what we call the centrosaurs, which will usually have a small orbital horn. That's kind of the image here, more of a top-down view of a dinosaur called Styracosaurus. So they'll have small orbital horns kind of around the brow, but a really large nasal horn. And these generally will have really elaborate frill structures. They'll have waves or spikes coming off of them and things like that. The opposite are chasmosaurines. So these are a little bit more of the more boring ones, but they are actually the more larger body sized ones. So this is where Triceratops comes in. So you can see body size differentiations between that and the bottom. So on the left side, we have more of the centrosaurians. On the right side, we have more of the chasmosaurians. So in the chasmosaurians, they will actually do the opposite. Generally, they will have a smaller nasal horn and really large brow horns. So these orbital horns. Their frill might still be pretty big, but it might be a bit um, more boring. So not as many spikes, not as many decorations as we would see in that of a centrosaurian. However, as there is with anatomy and biology, there's always exceptions to things. So in this image here, on the left, we have so on the bottom here, we kind of have some more basal ceratopsians like Protoceratops. Then we have just a whole variety of different types of horn structures. These ones being primarily which ones? We're going to be looking at primarily the ones that have the small orbital horn or the large nasal horn, right? So that's going to help us differentiate things. So the large brow horns, these ones are going to be more the chasmosaurians, whereas the ones with the large nasal horn are going to be the centrosaurians. However, that's not always the case. So there is some variation that kind of changes throughout here, as you can kind of see through all of these different types of species that are shown on here. And there's even more that have been named ever since this figure came out. All right, so that ends this lecture here. The next ones are going to be on the Saurischian type of dinosaurs. And that'll be in the new module.